right. So let's go ahead and jump into it, everybody. We're going to try and hit this one in 30 minutes today. Like we were just saying, it may be an ambitious goal, but we'll see. We may be doing some Q&A. If we got some questions, we're happy to stick around a little bit later, but trying to get something in a shorter time period. This will obviously be available on recording as well if you got to jump early. But the topic today is all around training, fine tuning, and inference. These are three kind of key concepts that are really important to know when you're talking about AI. So, if for nothing else, you're going to sound a lot smarter after this when you're talking to your engineers and whatnot. So we're going to go through what it is, and then we're going to do a little show and tell, right? I mean, David. David's going to do a little show and tell on the fine tuning side and also the inference side, and you'll begin
Yeah.
to understand like not only what they are but why they're important and what the impacts are, how does that impact use cases and all that kind of fun stuff. But yeah, with that, I'm going to turn it over to David to kick us off.
Okay. Thank you, Matt, for the introduction. And yeah, I think it's going to be a challenge to cover all of these topics in 30 minutes, but we'll do our best. And definitely it's going to be a fun session. Um, So yeah, today's goal is to, as Matt mentioned, we are going to be talking about what is training, what is fine-tuning, and what is inference, and what are the differences in the context of LLMs in particular, but this is in general for everything related to AI and machine learning. Um, so yeah, let's get started. Um, so initially we're going to start talking about training, which might be one of the probably the more popular term from these three things that we're going to be discussing today, because I think everyone is hearing a lot about training, that OpenAI is training a new model, that this or a company is training a different alternative, that someone is training an open source version of something. So this is something that we are hearing all the time in the internet, and, and yeah, basically training. If we think about it as a human being, uh, and I like to think about this using this metaphor, is like um, it's like when a kid or a teenager go to mid school, to high school, and learn like all the basic stuff about world and how the world works, and you learn about lots of different topics to get like a general understanding about the world. So in terms of how this works for a LLM, it's kind of similar somehow. So as we know, LLMs are neural networks, and what we have on the screen right now is like a very typical representation of a neural network. In the case of LLMs, they are using a slightly different architecture, which is a transformer architecture, and we have discussed that on previous webinars. But this general representation of a neural network is still very useful. And basically what we have on the left is the way we initialize an LLM. So when we want to start building an LLM, um, we have something like what we have on the left. So we have an architecture, which is basically a set of parameters. In this case, many of you might be familiar with the term parameters in the context of LLMs. We know that for example, someone released a model with, I don't know, 20 billion parameters or 100 billion parameters, or even in the trillions parameters order. Here in this representation, our parameters are the yellow circles. So each of these, in this case, we have 12, but also we have 10 here, but in real life LLMs we have billions and sometimes trillions for many of the more recent models out there. So basically, as some might know, what an LLM is doing is that based on a context or a set of words, which in this case for this example are four words, which are basically the blue circles here. So we have, for example, in one circle the and the other students, and they're open and there. So we have the students open there, and basically based on that input, which is our context, we want to predict what's the most likely next word for it. So when we have an LLM initialized, this is going to be completely random, because as we can see here, the yellow dots or the yellow circles here have just like the same value. In this case, I randomly initialize this using the number 1 value for each of the parameters. So this neural network has no knowledge at all, so it will just randomly throw any word that it comes up with. So in this case, for this example, it's throwing the word sun, which is not related at all with the context that we have. So what we are doing in our training step for an LLM, and this is in general for every kind of neural network, is that we are feeding the model with lots of information. In the case of the latest LLMs that we have out there, this information that we are feeding is almost like the whole knowledge that we have available in the internet. So I have this quote here from Andrej Karpathy, who was one of the main researchers at OpenAI at some point, and he says like, okay, you can think about it, and it means about training a model as compressing the internet into the model parameters. So we are compressing like the whole internet knowledge or every open knowledge that we have out there into these parameters, which are the yellow values that we have here.
And just for context, like when
Yep.
Meta was training Llama 2, like Llama 3's out, which is like way more advanced, but even Llama 2, I had heard that it was several weeks and it was what, like 6,000 GPUs or something crazy to train it,
Yeah.
not to mention millions of dollars. So like this is like the very intensive step. By the way, Andres Karpathy, he's left OpenAI. Do you know what
Yeah.
have you heard what he's doing now, or is he still kind of
Not
incognito
really. I
mode?
think he's still like I don't know, like an open agent, uh
Yeah, that's
but yeah,
interesting.
yeah. Yeah, I don't have a clue what he's doing right now, but he's releasing lots of content in the
Mhm.
village, so, and it's very valuable content if anyone wants to take a look. If he has a YouTube
Yeah,
channel,
seriously,
and it's very,
go to
very awesome. Yeah,
YouTube, Google his name, and he's got lots of good stuff out there. So great
yeah,
resource for people looking to go deeper.
yeah, definitely. He's one of the probably one of the person that has more knowledge about this topic in the world, so it's awesome to watch his content. Uh, so yeah, coming back to this topic on training, basically training is about passing this information that we have been talking about to the LLM, and it will iteratively start updating all of its parameters so that the outputs that it is creating make more sense, are more accurate when compared to the data that we are feeding to it. So this might sound like very simple, like we are just predicting like the next word or the next token, but actually to be able to do that, the model is kind of yeah, it's kind of writing down a representation of the world in these parameters. So this is deeper than what it really seems initially when you first think about it, like just predicting a word. It seems like very simple, but actually what it is doing is that it's creating like some kind of understanding of the world, and it's represented in the set of parameters that we have, which in this case are the yellow values that we have here. So what we are doing on each of the iterations, when we start feeding it with documents, with different kind of text, what we call the corpus in the context of LLM training, is that we are going to start updating each of those parameters, each of those billions or trillions parameters, and trying to tune them so they have like values that in the end, after doing all the calculations that the neural network is going to do internally, is going to give a word that makes sense with the context that we are providing as the input. So that's like the general idea. The process of training a model, it's basically trying to tune all of these yellow circle here. Think about them like knobs. Like you have, I don't know if you're
Mhm.
familiar with sound and audio. You have like the mixer. You have lots of knobs, and you want to find like to tune them to get to the right mix for each of the channels. So it's very similar to that. You can think the process of training as tuning those knobs to get to the place where you want them to be. So the challenge there is that we require massive data sets because we want those parameters to reflect, as we discussed before, like some understanding about the world, and that requires lots of data, lots of books, article, websites, and any kind of large text corpus that we can find in the internet. So that's a challenge by itself. We need to guarantee that that data is quality data, it has diversity, and that also requires lots of post-processing to that data, and that of course leads to significant computational resources required for doing this, and this is often done using like distributed computing, using GPUs, TPUs, and very specialized hardware that is able to do parallel processing. Of course, another challenge that we have when training an LLM is that we need to handle those big computational resources, and that leads, to different kind of costs in this process of training. So this kind of limit the amount of companies that are working on training new models, because training these foundational models, as we call them, is very expensive, requires lots of knowledge, lots of data, and yeah, definitely not everyone is up to the challenge. So the companies that are out there training foundational models are, for example, Meta, which are training the Llama models, OpenAI, of course, Mistral, Anthropic, Microsoft. We have like these big names or these startups that are very well funded and that are very specialized in this. I know the tool that all of them are using are the NVIDIA GPUs, because it's the hardware that is currently doing the job. So that's why we have seen this like this boom in the NVIDIA stock in the latest
Yeah,
years.
I think it was yesterday, it just surpassed Apple as like the second
Yeah,
biggest company in the world, which is just insane. It's partial hype, partial this is what everybody's using right now. But I think too, like the way to think about this, say you're a business leader, you're not the technical person, but if somebody's coming to you and saying, "Hey, we got to build this brand new model, train this model from scratch," I would be very um hesitant, critical, ask questions, right? Because
yeah,
there's so many models out there, open source models now, and that's been the big shift in the past couple of years. Is
correct.
these are now accessible to really anybody and everybody. You almost I would equate it to like back in the days of when wireless was becoming big, they had to set up all the infrastructure and the fiber and think of like the training of these large models. This is like the setup of
Yep.
all that infrastructure that's been done. Trained on public data. It's not trained on your own private data. So I think that's where you get into kind of like this fine tuning and all the fun around that, which is the next topic.
Yep. Yeah, exactly. And one thing that is very interesting is that these foundational models, since they are so big, they are up to solve many different tasks. So they are different to what we used probably a decade ago, where we had models that were very specialized. So everyone had to train their own models. That paradigm is kind of shifting now that we have like these big foundational models that can solve many different challenges. So yeah, uh, now that we talked about training, let's talk about what's fine tuning. This is another term that we have been hearing a lot and might cause some confusion. Um, but basically, fine tuning is the process of taking a pre-trained model, so a model like the ones that we mentioned, that the ones that we already know, like Llama 3, like GPT-4, or any of these big models that we have out there already trained, and it's like further training them on a specific data set, so they are able to solve a more specific task, or they are better at solving something more specific. So we're going to see a couple of examples in a moment, but let's go back to our simple diagrams here. So let's take the same example. So let's say we have this model on the left. That is the one that we trained on the previous step. We have like the same values. These are the parameters that we trained before. Uh, but let's say we want to fine tune it to be able to, I don't know, to predict something in the context of fantasy and magic. So basically, we want to fit this new model with a corpus of data that is related to that topic. And what we are going to do is that we are going to add some additional parameters, or we are just going to take a small set of the parameters of the model, and we are going to modify just a small set of them. Because the naive approach will be like, okay, I can pass like this new corpus of data that I have, in this case related, for example, to fantasy and magic, um, and I want to fine tune all the parameters. That's going to be as hardware and time consuming as training the whole model. So that's not feasible in many use cases. So there are many techniques out there, like for example, LoRa or QLoRa and many more. This is a very trending topic in the research field. Because basically we are looking for ways to optimize this fine-tuning process. But in general, most of what most of these approaches are doing is like that they are adding some additional parameters, which in this case in the image on the right are the red ones, and we are only tuning those parameters. We are initializing them, and it's like we are repeating the training process using this new data, but we are only going to modify, in this case, the red circles that we have here. So we are not going to modify the whole neural network. And the output is going to be something like this. So in the previous example on the left, we had the students open their laptops, but if we fine tune this with this kind of corpus with fantasy and magic setup, it's going to be something like the students open their spell books. So that's going to be like the predicted token or word, because it's basically what we are fine tuning it to be able to do. So we can think about many use cases for fine tuning. You can fine tune a model with, I don't know, your own business data, so it's able to understand your the context of your own business, that is not open data. So these big foundational models don't have that knowledge. So you can think on use cases like that. For example, you can think about, I don't know, use cases where you want this to be able to do something very specific and do it better than how a bigger model, I mean, how a foundational model will do it. So yeah, this is basically the concept behind it. And following the metaphor that we discussed before, this is like, okay, now you have like this mid-school and high school knowledge, which is very general, and you want to specialize in something. So you go to college and study, I don't know, software development, for example, and you get very good at that. So this will get you deeper into that knowledge. So it's kind of what we are doing when we are fine-tuning a model. So the
So you
good
fine
thing
tuned here
about it,
on the Harry Potter book series there, right? Uh,
yeah,
but the one thing I found interesting when we were chatting, David, like
yeah,
I think before you'd mentioned sometimes you would be adjusting the parameters of the model itself in the past, but that's what's interesting. Like you're not touching this foundation
exactly.
model. Like, and if you tried to do that, that again would be insanely expensive. You're adding
Yeah,
this layer here, and that's like again for business folks or product folks or whoever on the call, that's a critical thing because this is where you can tailor, hence the word fine tuning, fine tune the model for your specific use case. And like we said before, there's a ton of data on the internet, but there's probably even more private
yeah,
and
exactly.
proprietary data that exists. So that's where you can make it your own. And then even like talking, you hear people talk about AI agents all the time. Like this is also in that kind of context where you could tailor an agent for a very specific use case, purpose, how they interact, all that kind of stuff that you could fine tune.
Yep, exactly. So yeah, following what you were saying, yeah, if you see on this example here, we're not modifying the yellow circles, so the values on the yellow circles are exactly the same because that's like the foundational knowledge of the model, and we are only adding like this new layer of red circles, and we are only modifying those. So yeah,
Yeah.
it's basically like the approach that many of the fine-tuning techniques are following. So the good thing about that is that, okay, even if we require a lots of hardware and lots of time to train a model from scratch, it is possible for us to fine-tune models in a, you know, in a more human accessible context. So yeah, let's do that. So let's take a look at how that might look like. So I decided to bring this notebook, which is a very popular notebook for fine-tuning using a Python framework, which is PyTorch, and using bits and bytes library also. So what we are going to do here is that let's look at the result first. So we have a small model that we want to fine tune here, which is in this case Flantify. That's a model released by Google to be able to generate like summaries of dialogues and conversations. So we have the base model here, and if we request the model and we prompt it like this way, let's zoom in a bit. So I passed like this conversation where Mark said, okay, I just shipped the goods. Mark says again, tomorrow I'll send you the tracking number. And George says, thanks, for example. And this is going to like capture the idea behind the dialogue and generate like a summary. So what it's going to do is, okay, the result that we get from the model is like, Mark will send George the tracking number. So that's what we're getting with this base model. So it's kind of, I mean, that's kind of true. Mark is going to send George the tracking number, but I think it's kind of losing some of the context because this is a general model and it's not a, I mean, it's not specialized on understanding like dialogues and generating summaries. So what we want to do in this example is that we want to fine tune it to be able to be very good at that particular task of summarizing dialogues. So for that, as we mentioned, we'll need a specialized corpus of data. So in this case, this is the corpus that we are going to feed. And if you see here, what we have here is like a bunch of dialogues and summaries. These are handmade summaries. That's how many of these data sets are done. You need human work here, so the model can learn from that. So we have a bunch of them, thousands of dialogues with each of their summaries. And what we want to do is that we are going to pass that knowledge or that corpus of data to the model so it can, using a technique which is called LoRa, we are going to generate these new parameters, which are like the red circles that we have in our deck. And we are going to fine tune those values to make the model more capable on that particular task. So this is basically what we're doing in this notebook. We're not going to get into like all the technical details because there's lots of things going on here, but we are going to talk about like the generalities here. So we are going to load the dataset that I just described, which is called Samsung dataset. It's a very popular dataset with 16,000 messenger-like conversations, exactly the ones that we just were just looking at. So here is an example of one of them. We're going to load that dataset. We also need to load our model. So this is very interesting because we are going to load in this case Flantify. That's still a big model. It's a model with around 1 billion parameters, which is small for nowadays standard, but it's still a kind of big, so you will need to have enough memory, which in this case is GPU memory. So Colab, for example, which is the environment I'm using here, is very useful because you can allocate GPUs for very low price. So for example, here I'm using an L4 GPU. This costs probably less than, I mean, the subscription that I have that allowed me to do that costs less than $10 a month, for example, and it will allow you to do fine tuning on models like this, for example. Compared to the cost of training a model like this, it will require probably, I think training this model took like 8 A100 GPUs, which is probably renting that for 10 days, which was the time required to train this model. Could be probably around, I don't know, $1,000 compared to, I don't know, if we divide the time that we use here by the price of the subscription, fine-tuning this could be just a few bucks, probably $2 or $3 to do this fine-tuning. So it's completely different
I like
thing.
that math. That's good.
Yeah, so it's completely different. So even if we require hardware here as well, it's in a completely different league than training the model from scratch. So yeah, we are going to load the model in our in memory, basically. We are going to process our corpus of data. We need to tokenize that data because the LLMs don't work with words. They work actually with numbers and vectors. So that's something that we have discussed a bit in our webinars also, and there's lots of content out there. But we need to tokenize our corpus and transform that into vector embeddings. And yeah, then what we are going to do is that we are going to apply the LoRa approach. we are going to define like some parameters on the LoRa, and here is something that I wanted to show you. So here basically I'm printing like the total number of parameters for the mall, which in this case is this value here. It's above 1 billion parameters, and these are the trainable parameters in our LoRa setup. So we have 18 million in this case, and we can calculate like the percentage of trainable parameters, which in this case is just 0.16% of the parameters of the model. So that's the amount of parameters that we are going to be modifying in this fine tuning instead of use or of training over the 100 percent of the parameters, which is going to be insane. So yeah, basically we are going to set up our LoRa training, and actually here there's a training running. I wanted to do this just to show you like if this is possible using a setup like this, using an L4 GPU in Colab. So this is a training that is in progress, a fine tuning that is in progress. Sorry. So this we have been running this for 12 hours. There's like 5 hours left. So this is something that will take like 17 or 18 hours in total. That's still some time, but we are using like some consumer grade hardware in this case, which is an L4 GPU. And I also mentioned before, like the price of this is very low. So even though it takes some time to do the fine tuning on this kind of hardware, it's completely doable, and it's something that we can think about doing on consumer grade GPUs, even some of those gaming GPUs that we found out there with enough memory, like for example an RTX 4090 or even a 3090. We should be fine for doing this kind of process for the small models. So yeah, basically I want also to show the result here. So there's a fine-tuned model already uploaded in Hugging Face, which is a big repository. So I want you to take a look how the result looks like. So we saw the request to the base model, which was basically this was the answer that we got. Mark will send George the tracking number. But now we can request to the same model, but instead fine tune on the Samsung dataset, which is exactly what we just did. And in this case, we're going to get a more detailed summary. We're going to get like, Mark has just shipped the goods. Tomorrow he will send George the tracking number. So it's a more detailed description about the dialogue that we are trying to summarize. And this is exactly the same model, just fine-tuned using this data set that we were just presenting. So this is just for you to have like the idea of the kind of things that we can do with fine-tuning and how we can make models be better at specific tasks out there. And in Hugging Face, you will find, which is a very awesome repository, you will find lots of fine-tuned models that are tailored to be better at doing specific tasks for compared to, for example, the the foundational model version.
For
So yeah,
those that don't know, that is the cooking show method right there. We put the cake in the oven and it magically was done on the back end. So good example of that.
exactly.
But yeah, so we're at time, but we're gonna keep going. We're gonna hit inference next. If anybody has to drop, check out the recording. You can catch the inference stuff. But the inference piece is
Okay.
really interesting as well to kind of put a bow on these three concepts.
Yep. Exactly. So yeah, now we are going to talk about inference. So what is inference? So in both training and fine-tuning, we're adjusting some parameters. In training, we are adjusting all of them, or the yellow parameters, and in fine-tuning, we are just adjusting some of them, in this case, the red ones. But on inference, we are not going to adjust parameters anymore. We are going to use like the model as it is to be able to make inference of new tokens or new words. So this is exactly what we are doing when we use ChatGPT or when we go to Perplexity or any of these LLM providers out there. Basically, what we're doing is inferencing. So we ask a question and it's going to inference the next words of or tokens based on its knowledge or based on its parameters. So the good thing about this is that inference is much less hardware demanding, even though for LLMs it's still somehow demanding. It's not as demanding as training or fine tuning. And this is what we are going to be using in many real case scenarios. I mean, we train models and we fine tune models, so we are able to do inference on those models and get the answers that we want to get. So
And
this
back
is
to your
actually,
example earlier, this is like you went to the general school, then you wanted to
oh yeah,
specialize in software development, it's like fine tuning. Inference is kind of like, okay, you have all this experience, now you're applying it to your
yeah,
trade or
exactly.
some project, right? So you've already built up all the knowledge. Now you're applying
Yeah.
it and output.
Yeah, exactly. You are applying it to get the work done now. So yeah, that's exactly what it is. So this is very interesting because one of the challenges that we have today is the inference speed. So many use cases rely on having a fast enough inference speed. So for example, I don't know, a use case that require like real-time responses from LLMs. I think many of us have faced the situation where we go to ChatGPT and it takes like probably lots of time to answer. That improved a lot with their latest release. Um, but there's lots of research on this field nowadays, and even today we have this company Grok, which is developing chips. It's like I know they are developing chips that are comparable to GPUs, but they are specialized only in doing inferences. So they are
Mhm.
very good at doing that. So it's a chip that can do inference way faster than any GPU out there. And it's very mind blowing. So let's take a look at it. They have a small demo here. So. Um, let's ask something to ChatGPT like what's the difference between training and fine tuning, for example. So we can ask this to GPT-4o, so it starts inferencing. Each of these words that it's putting here is the result of an inference process. So yeah, we go to our response. So now let's go to Grok Cloud and do the same. I'll ask the same question. So Grok is not a model provider; they're a hardware provider, but they have lots of models, like for example, in this case, Llama 3, 8 billion parameters deployed on their cloud and running using their hardware, so we can do very, very fast inference. So let's do the same question. What's the difference between training and fine tuning? And if you see it already generated the response, so it's mind blowing. And it even reports the speed, so it's generating 1,254 tokens per second, which is insane. I mean, ChatGPT, for example, was able to generate around 40 on its previous version. Now on the newer version, the GPT-4o, it's generating around 100, which was a great improvement, but anyway, this is completely in a different level. So this is insane that things like this are being developed
Yeah. And they got a neat
today.
Discord community if anybody's interested that's out there. A lot of people are starting to develop using Grok on the inference side, which is interesting.
Yeah, yeah, exactly. Um, okay, so this enable lots of things. As I mentioned before, this enable real-time applications, better user experience, more scalable infrastructure, and the opportunity, for example, to do edge computing. Nowadays, most of the LLMs are running on cloud because doing inference, even though it's less expensive than training and fine-tuning, it's still somehow demanding. So most of the computation is doing on cloud. But this kind of developments and things like what Grok is doing will enable at some point to do edge computing on IoT systems, or this opens lots of opportunities. Um, so yeah, we even have
Hey,
here
my friend
like
and I are
the
learning Spanish, and
like the demo that was released by OpenAI a few weeks ago. This was a major improvement because they moved from GPT-4 to GPT-4o, and one of the major upgrades, I will say, is like the inference speed. They were able to to duplicate the speed or something like that. So that enable them to be able to generate things like what we're going to see in this demo. So let's take a look.
Hey, my friend and I are learning Spanish, and we're wondering if you could tell us the names of these objects in Spanish.
Hola, por supuesto.
Cool. What are these objects in Spanish?
The objects you're showing are una manzana and un plátano in Spanish. Nice fruit choice.
Cool. What about these?
Those are dos polígrafos or dos plumas in Spanish. One is red.
Nice.
Yeah.
What about this?
That adorable stuffed animal is un oso de peluche in Spanish. Looks like it's ready for some hugs.
And what's cool there is like, I don't know if anybody's interacted with the voice feature on ChatGPT, but you say something like you could ask a similar question, and then it sits there and thinks and thinks. Then it gives
Yeah.
you a response. Then you got to ask something back. Then it sits there and thinks and thinks, and it's just not a great experience. But if you notice in that video, it was like having a conversation with a human. It was real time in nature. So like I think that's another angle. Like just with everything going on with AI from the business product engineering side, like think of what this can enable in your business when things can be real time in nature with some of the increased inference speed. And I think David, like the inference speed, it's just one of those things we're going to continue to see improve over time, just like everything else going on right now.
Yeah, yeah, definitely. There's lots of research on that area, and there are companies starting to show up like this Grok company, and there's lots of development on this side because yeah, I think it's one of the major limitations that we have there to be able to generate like more human-like agents and like more immersive experiences. And yeah, this will definitely enable lots of real-life applications that without a good inference speed are just not feasible. So yeah, there's lots of development in this area as well.
Cool. So let's hit quick Q&A. If anybody's got questions, drop them in the chat. I got one here from Luis. So he's asking, this was when you were going through kind of the fine-tuning process, but he was asking if we have the documents, we could have an agent or even a custom GPT to transform the text into JSON and create the training data format to train the model. How would one avoid overfitting any recommendations? So I think if I'm understanding correctly, Luis, this is almost getting to that point of like the type of data you're fine tuning and training on. I don't know if it's getting into like synthetic data too, which could be an interesting future topic, but any thoughts around that one? David?
Yeah, I think yeah, I think what he's mentioning is related to, yeah, we have like tools like ChatGPT now that can transform like the format of the corpus of text into the format that we require to be able to provide to a framework like Bits and Bytes and PyTorch to be able to do the fine tuning. And I think that will enable us, where I think there were like two different questions, like how we will avoid overfitting in this case. Yeah, as I mentioned, so neural networks are definitely sorry, LLMs are still neural networks. So many of the techniques that we use to avoid overfitting, and overfitting for those who are not familiar with the term is basically when a neural network learns like the specific like the specific things about your data set and is not able to generalize well enough, so it's like overfitted to that data set. So there are many techniques out there to avoid that, and that's why we are using a framework like PyTorch, which give us lots of control on the parameters that we are using. It will allow us to, for example, to use dropout. It will allow us, for example, to I don't know, we should have also a validation test, sorry, a validation set. So it's like in traditional machine learning where we split our training set into training, testing, and validation. So we can do techniques like cross validation, and we can detect this kind of things. So it's the same thing. So for example, this Samsung dataset that I showed on the example, it's divided into training, test, and validation sets. So we are able to validate and try to be aware if we are having overfitting or underfitting, which is the opposite, that it's not learning anything at all. and we can then use techniques like dropout, for example, to be able to try to reduce the overfitting in these cases. So yeah, it's very similar to what we did in traditional deep learning or machine learning training.
Cool. All right, I don't see any other questions. If y'all have some, drop them in. If you want to chat after, just reach out to us, either David or I directly, or just go to hatchworksai.com and drop us a note there. Just a couple things to note, check out the community. We got all the recordings in there. So if you want to check out some of the old episodes around small language models, we're using it in Gen AI and software development. There's one around multimodal models. So several good ones we got in the past you can still check out. And then future ones, we'll get a new one up very soon. We're thinking around a topic around agents. There's, the one of synthetic data that came up today. There's some deeper dives on RAG specific use cases. We got some interesting ones in the HR space that may be interesting to get into in the future. But yeah, when I end this, it'll give you a survey, give us some feedback, let us know what type of topics you want to hear. And I think we can wrap it up there. But thanks everybody for checking out this GenDD lab, and have a
Thanks,
good
everyone.
rest of your week. Bye.
See ya. Bye bye.